The Virginia-Class Submarine, America's unseen titan of the seas. It's 2030 and the Pacific Ocean is a battleground. The United States is entangled in a high-stakes naval war with China and Russia, where control of the seas dictates global power. Deep beneath the waves, 1,300 feet down in near-freezing darkness, 134 sailors aboard a Virginia-class submarine work in the eerie red glow of combat lighting. Their screens pulse with data, sonar pings, navigation charts, and tactical feeds. Somewhere in these murky depths, an enemy vessel, a Chinese Type 093G or Russian Yasen-class submarine, desperately tries to stay hidden. It's a futile effort. The Virginia-class, led by its namesake USS Virginia, is the most sophisticated underwater predator ever built, a $4.3 billion masterpiece of American engineering. Born from Cold War lessons and refined to counter modern threats, this submarine ensures U.S. dominance in an ocean growing more contested by the day. Let's dive into the evolution, innovations, and unmatched capabilities of the Virginia-class and explore why it remains the apex predator beneath the waves. The legacy of Cold War submarines. To grasp the Virginia's brilliance, we must first revisit its predecessors. During the Cold War, the Los Angeles-class submarines were the U.S. Navy's workhorses. With 62 vessels, these fast, lethal hunters patrolled the oceans, tracking Soviet submarines and surface ships. Armed with 4 torpedo tubes and, later, vertical launch systems for Tomahawk missiles. They were formidable, but by the late 1980s, cracks appeared in their dominance. The Soviet Union's AUKUS-class submarines, with acoustic signatures so quiet they rivaled Western designs, threatened America's edge in detection, the lifeblood of submarine warfare. A single undetected enemy sub could sink a carrier group or disrupt supply lines, shifting the balance of power. The U.S. countered with the Seawolf class, a technological marvel designed to crush any rival. Launched in the early 1990s, the Seawolf boasted 8 torpedo tubes, a near-silent profile, and the ability to fire Tomahawks against land targets. It could dive deeper, move faster, and detect enemies at ranges that made it a nightmare for adversaries. But its $5.64 billion price tag, in 2025 dollars, was staggering. The Soviet Union's collapse in 1991 slashed defense budgets, and only 3 Seawolves were built before the program was axed. By the early 2000s, the aging Los Angeles fleet faced obsolescence, while Russia's Yasen-class and China's expanding naval ambitions loomed. The U.S. needed a new submarine, affordable, versatile, and future-proof. The birth of the Virginia-class. Enter the Virginia-class, a program launched with an ambitious goal: deliver 90% of Seawolf's capabilities at 70% of the cost. Conceived in the 1990s and first commissioned in 2004 with USS Virginia, it exceeded expectations, redefining submarine design. Unlike its predecessors, the Virginia was built entirely using computer-aided design CAD. Every pipe, wire, and valve was modeled in a virtual 3D environment, eliminating costly physical mock-ups and saving hundreds of millions in development. This digital approach allowed engineers to simulate performance, identify flaws, and optimize systems before a single weld was made. The command center, the nerve hub of the submarine, was revolutionized. Traditionally, control rooms were built inside the hull, requiring complex retrofits for upgrades. The Virginia's modular command center is constructed and tested off-site, then installed as a plug-and-play unit. This allows seamless upgrades. New computers, sensors, or software can be swapped without cutting into the pressure hull, ensuring the submarine stays cutting-edge throughout its 33-year lifespan. The hull itself saw a bold innovation. Traditional periscopes, which required hull penetrations and were vulnerable to damage, 9 submarines suffered periscope hits in World War II, were replaced with photonics masts. These retractable digital cameras, equipped with infrared and high-resolution lenses, feed imagery to high-definition displays in the control room, enhancing situational awareness and eliminating structural weaknesses. Power and stealth, engineering marvels. At the heart of the Virginia lies the S9G pressurized water reactor, generating 30 megawatts to drive the submarine beyond 35 knots, over 40 miles per hour. Unlike older designs requiring midlife refueling, the S9G powers the Virginia for an entire 33-year service life without refueling, saving billions and keeping the submarine operational longer. This eliminates lengthy overhauls that sideline Los Angeles-class subs for years, ensuring more time at sea. The reactor's efficiency, combined with advanced cooling and insulation, minimizes noise, a critical factor in stealth. Submarine warfare is a deadly game of hide-and-seek, where the first to detect wins. The Virginia is a master stealth, coated with anechoic tiles that absorb sonar pulses, giving it a smaller acoustic footprint than many smaller submarines. Acoustic quieting isolates every pump, motor, and system on vibration-dampening platforms, preventing noise from radiating through the hull. The large aperture bow lab sonar array, using lightweight fiber optic cables instead of copper, detects faint signals from quiet adversaries at ranges previously unimaginable. The pump jet propulsor, a shrouded rotor replacing traditional propellers, reduces cavitation, the noisy bubbles that betray a submarine's position. This allows the Virginia to sprint at high speeds while remaining quieter than older subs running silent. A lethal arsenal, the Virginia's offensive power is staggering. For 21-inch torpedo tubes launch Mk-48 ADCAP torpedoes, autonomous weapons that exceed 55 knots and carry warheads capable of splitting open any ship. These torpedoes use active sonar to hunt targets independently, making them relentless predators. For land strikes, early Virginias carried 12 vertical launch system VLS tubes for Tomahawk cruise missiles, capable of hitting targets 1,000 miles away with pinpoint accuracy. Blocks 3 and 4 replaced these with 2 Virginia Payload tubes, each holding 6 Tomahawks, simplifying maintenance. The Block V introduces a Virginia Payload Module VPM, an 84-foot hull section with 4 large-diameter tubes, each carrying 7 Tomahawks, boosting the total to 40 missiles, equivalent to a small air wing's firepower. Beyond conventional weapons, the Virginia supports Special Operations Forces, SOF. A lockout trunk allows SEALs to exit while submerged, and a dry deck shelter houses specialized delivery vehicles like the Advanced SEAL Delivery System. Unmanned underwater vehicles, UUVs, extend the submarine's reach, performing reconnaissance, laying sensors, or attacking targets without risking the $4.3 billion vessel. This versatility transforms the Virginia into a multi-domain platform, capable of anti-submarine warfare, land strikes, and covert operations. A sci-fi control center. Step inside a Virginia-class submarine, and you're in a futuristic command center. The submarine command system integrates sonar, navigation, and tactical data on high-definition touchscreens, replacing the analog wheels and dials of older subs. Running on 4 million lines of code over a fiber-optic network, it monitors propulsion, weapons, and life support, automating tasks to maintain a crew of 134, comparable to the Los Angeles-class despite greater complexity. This requires highly trained sailors, meeting the Navy's stringent standards for months-long underwater missions. The fly-by-wire system, using joysticks to control rudders and diving planes, delivers unmatched maneuverability, executing tight turns and rapid dives impossible for earlier designs. Crew comfort is enhanced, a necessity for long deployments. Larger bunks with privacy curtains, reading lights, and personal storage ease the psychological toll of isolation. Advanced ventilation and water purification ensure a livable environment, while noise reduction creates a quieter interior, reducing stress. These human-centric designs reflect lessons from decades of submarine operations, balancing technology with crew endurance. Multi-domain mastery. Unlike Cold War submarines built for deep ocean duels, the Virginia thrives in complex, literal environments. Its sail is reinforced to break through Arctic ice, critical as melting ice opens new trade routes contested by Russia and China. The lab array excels in noisy coastal waters, detecting quiet diesel-electric submarines used by adversaries like China. Operating in waters as shallow as 300 feet, the Virginia conducts intelligence gathering, SOF insertions, and strikes where surface ships are vulnerable. It excels in access denial, neutralizing enemy defenses to enable carrier groups or amphibious forces to advance. As Ohio-class guided missile submarines, each carrying 154 Tomahawks, retire, Block V Virginias fill the gap, ensuring the Navy's strike capacity. The submarine's electronic warfare suite intercepts radar and communications, while photonics mass capture high-resolution imagery of enemy bases or ships. Its ability to tap undersea cables, carrying 95% of global internet traffic, grants access to an adversary's digital backbone, a strategic edge in cyber warfare. Industrial innovation and challenges. The Virginia's construction is a triumph of efficiency. Built modularly across General Dynamics' electric boat in Connecticut and Huntington Ingalls Industries in Virginia, major sections are assembled simultaneously, then joined, cutting build time from 84 months for early boats to 61 months, with a goal of 55. This contrasts with the USS Gerald R. Ford carrier's two-decade construction. The approach revived the post-Cold War shipbuilding industry, retaining skilled workers and reducing costs from $2.8 billion to $2.4 billion per unit, though upgrades raised prices to $4.3 billion. The program evolves through blocks. Block I established a baseline. Block 2 cut costs. Block 3 introduced Virginia Payload tubes, saving $100 million per boat. Block 4 reduced maintenance, boosting deployments from 14 to 15. Block V added a VPM, increasing displacement to 10,200 tons. Yet challenges loom. Production lags at 1.2 submarines annually against a target of 2, with only one order for 2025 at $4.8 billion, due to inflation and supply chain woes. The AUKUS Pact, promising 3 Virginias to Australia by 2038, strains the fleet, as these will likely come from U.S. production. Critics warn the program is decade behind, risking gaps in capability as threats grow. Facing the future. China's Type 093 Yasen-class and Russia's Yasen-class submarines are formidable, with advanced quieting and missile systems. Yet, the Virginia's stealth, versatility, and upgradability keep it ahead. Its digital architecture supports rapid software updates, and Block 6 may integrate Columbia-class technologies, like the X-Stern for enhanced control. The Navy's SSN-X program, a larger successor 11% bigger than Seawolf, will feature electric drive motors and greater payloads. UUVs like the Orca will extend capabilities, handling mines and electronic warfare. The Virginia's ability to loiter undetected near enemy shores, mapping defenses or launching strikes, creates a psychological and strategic edge. Adversaries must assume it's always present, diverting resources to detection. In an era of hypersonic missiles and AI, the ocean's unmonitored depths remain a domain of unmatched advantage. The Virginia-class, with each new hull, reinforces America's ability to strike anywhere, anytime, without warning. What do you think? Is the Virginia's cost worth its dominance? Or should the U.S. shift focus other domains like space or cyber? Share your thoughts below, and thanks for joining Armies of the Past.